Good morning, students. So we'll move on to the last topic of machine independent features of assembler, that is control section. So in previous lecture, we were discussing about like how we can provide the expression as an operand. Okay, then later, what is program block? How many different sections we are having? Okay, like C block we are having. Okay, then C data we are having. Then C block we are having. Then default we are having. So such type of, okay, how the main program will be divided into subprograms, regarding that we study. So in today's session, we'll be discussing regarding the control section. Okay, means, so just observe, one main program will be available with, okay, but to generate the proper result, what we do, we are dependent on subprograms. We are calling it as a subroutine programs exactly. So here main program, if you are calling it as a one control section, if you are having 10 different subroutine programs, okay, whenever we are having the requirement, then only we will be calling them, okay. But if it is available, then we call it as 10 plus 1, total 11 different control sections are available. Okay, so we'll be discussing regarding this control section. We don't want logic of the program. We need to analyze, or we need to understand how your assembler will deal with these kind of a control section. Yeah, okay. Control section means what? Some logic will be available in particular section. Okay, so they will be generating some output exactly. But few information which is available in the one control section may be used by the other control section, or which is available in the information which is available in the another control section, it may be used by the main section. Okay, there will be a switch between the information switch between the one control section to another control section, or one subprogram to another subprogram. Okay, now how your assembler is going to deal with such type of a control section, we'll discuss. Okay, the control section is a part of the program that maintains its identity after assembly. Okay, see, up to we assemble the program, we don't have any issue like, okay, how many number of control section you are having, where they are residing, and all that doesn't matter exactly. After assembling the program itself, we will get to know like, yes, these are the control sections available exactly. Each control section can be loaded and relocated independently of the other. Okay, it is not compulsory like if you are placing the main program in one part of the memory, then the subprogram must be also available in the same part of the memory itself. Okay, it may be independent. Okay, like relative kind of data storage is not at all required between the control section exactly. Okay, as I mentioned, total 11 different control sections are there. Okay, according to my example, it is not compulsory like 11 must be there. It may be 1, it may be 2, it may be 3. Okay, it doesn't matter exactly. Okay, if 11 control sections are available, 11 may be stored in different part of the memory. Okay, it is not compulsory like it should be stored in the proper order. Okay, then different control sections are most often used for subroutines or other logical subdivisions. Okay, so for dealing with the subroutine and the subdivision of the program, okay, we'll be expecting these different control sections exactly. Okay, we'll see this. Okay, there should be some means for linking control section together. Obvious, okay, they can be stored in any location of the memory. Then obviously some mechanism or some logic should be available. Okay, so that we can connect them internally. Okay, for example, instruction in one control section may refer to the data or instruction of the other control section. Possible. Okay, like if control section A is stored in location called as XYZ. Okay, if we are having another control section called as B, which is stored in location called as SMN. Okay, then we need to have some logical relationship between these two locations or these two control sections exactly. Because sometimes the control section of A, okay, what all the operands they are using, they may be defined inside the control section itself, or some may be defined in another control section also, okay, which is called as B example. So we need to have a connection between these two control sections. Remember, they are all single program, but they are having a different control section. That's it. Since control sections are independently loaded and relocated, the assembler is unable to process these references in the usual way. So up to now, whatever this straight line sequence we were following, okay, that cannot be or that may not be followed using when we are dealing with the control section. Such reference between different control sections are called as external references. Okay, so this concept we are internally calling it as external references. Okay, means the control section A is having some reference for the control section B, or control section B may be having reference to the control section C, or vice versa, any kind of it. Okay, so we are calling it as external reference. So our assembler must be in a position to handle such type of external references over there. Okay, we see that how we can go for dealing with these references in the. Okay, here we are utilizing some directives and we will be utilizing some logic, okay, to deal such type of references in there. The assembler generates the information about each of the external references that will allow the loader to perform the required loading. Yes, obvious. You are assembler. Okay. So if there is a such type of control section stored in different areas, stored in different location, then obviously the assembler will identify such type of operand or such type of a name, okay, which is having the external reference or which is having the influence of another subprogram. Okay, it will be indicated by the assembler for the linking exactly, or for the loaders or linkers exactly. When a program is written using multiple control section, the beginning of each of the control section is indicated by the assembler directive. Okay, we are using one directive for identifying the control section. Okay, C section, SECT. Okay, SECT stand for section, C stand for control. Okay, together we are calling it as C section. See, before this, we may use some labels also. Okay, we may use some labels also. Okay, like that second name we are calling the SCC name we are calling it as second name. Okay, like for the control section, we may be naming it as read data, we may be naming it as write data. Sometimes we may be naming it as a name of the program, sometimes copy. Okay, such type of example we are having. Next slide, we will be finding the program. Okay, where we can identify such type of a directives and such type of a second name for the directives. Okay, then separate location counter for each control section. See, one more thing. We need to have an updated location counter to deal with the different control section. See, if you are dealing with the first control section, okay, fine, 0 to 1000 is the first control section. After that, you need to reset your location counter so that you can start with the new address for the new control section exactly. This is very important. Then control sections differ from program blocks in that they are handled separately by the assembly. So in case of program block, whatever we had, like we had first one default part, right? Then later C data we had for managing the little amount of information. Then bulk of information, if it is available, then we go for a C block. Then there we had three different sections exactly. Is it right? Okay. Such type of arrangement we don't have over here. But we do have some arrangement, but the handling of the program block is totally different when you are comparing with the control section example. Then symbols that are defined in one control section may not be used directly in another control section example. Okay, they must be identified as external reference. Okay, for the loader to handle. The external references are indicated by two assembler directives. See, as I mentioned, some information may be defined in one control section, may be utilized by another control section. Example, value of XYZ, which is there in control section A, may be utilized by control section B also. Sometimes possible. Okay. The original definition is available in A, but it is utilized in A and also in B. Okay, then we are calling it as external reference or external definition. Okay, so now here, if you want to deal with such type of an operand or such type of an information, then we need to be dependent on two different directives. We are naming it as external definition and external reference. Be careful, there is a small change, okay, between these two definition and references. So first we will deal with external definition. Okay. It is the statement in a control section. What is that external definition stand for? It is the statement in a control section. Okay. Names, symbols that are defined in this section but may be used by other control section. Okay. See here, the symbols or the name, whatever you are defining in the particular control section, okay, may be utilized by the another control section, okay, then we are calling it as external definition. Remember, so whatever the operands you are declaring under this external definition directive, they are defined in that particular control section, but they may be utilized by another control section also. Yeah, so control section names do not need to be named in the external reference as they are automatically considered as external symbols. So here, no need to mention like which particular control section is calling for this operand. The name of that is not necessary exactly. So in further slides, you will be getting into know like how it should be defined or how it should be called and all. It's very simple. We need to use a directly called as external definition in front of that, the name of the operand, which can be referred by other control section exactly. Then later, if you are okay, fine. Next one. Okay, I would like to explain about the reference also. Later, I will take this example. But the external reference. Okay, so ext ref we are calling it as. It names symbols that are used in this section, but are defined in some other control section. So now, if control section B want to utilize some operands which are defined in A, then we need to go for a directly called as external reference. Okay, and in front of that, we need to mention all those operand which is not defined in the current control section, but it is defined in some other. Okay, such operand name only we need to specify. That's it. It is the job of your linker. It is the job of your assembler to find where exactly they are residing. Okay, on which control section they are residing. Okay, and to find the original address or original value of that particular operand exactly. Okay, but we need to use these two directives to identify which are called as a definition and which are called as a reference. The order in which these symbols are listed is not significant. Okay, the assembler must include proper information about the external references in the object program that will cause the loader to insert the proper value where they are required. Okay, so here up to now, like up to this discussion, we don't have any significant arrangement like how this external reference or your what we are calling the external definition should appear. Okay, for that we are having proper syntax that we will be observing in next slides. Okay, like how it will be identified in that. So you can observe here we have a two different control sections. Third one, like it is available in your textbook. Just observe. Okay, like for writing the record, we have one more figure. Okay, but the complete information is available in this slide exactly. See here, so this we are calling it as that second name. Okay, here we are starting. See, just observe start, but here we are not using a directive. Observe it. We are supposed to use this directive, right? C section. Okay, but here in case of this, we are not using that C section, but still we are considering it as a control section because it is the start of the first control section. Okay, if you are not using the C section also, it will be considered as like that's why we are calling it implicitly defined as an external symbol. Okay, yeah, specifying that yes, it is a control section. First control section we are calling it as. Okay, because it is in the beginning. Okay, first control section we are calling it as. Okay, and now just observe very closely. Okay, see next to star, we are having something called as external definition, external reference. Can you observe this? Just observe it as a external definition, external reference. I told you external definition means are the operands which are defined in this control section. Means the value of this buffer is available in this section itself. Value of bufferand is also available. Value of length is also available. All these three are the values are available in this section. Okay, but we may use this operand in another control section itself. Okay, so we'll see that what are those. So such type of operand we are declaring under definition itself. Okay, reference means what? Read record and write record. Actually, these two words are not defined in this control section. Means we don't know. Okay, we don't know what is the value of read record and what is the value of write record exactly. But still we are using here. That's why. Okay, actually these two values are defined in control section 2 and control section 3 exactly. Okay, from this we can get to know like what is read record. From next one, third one, we can get to know like what is write record exactly. But like currently we don't know what exactly. So what we do, We are writing it as external reference. Okay. So here, just observe wherever we are using external references over here. See here one part external reference we are using read record, which is not at all declared. Okay, we don't know what is the value of read record. We don't know what is the value of write record. See here, write record we are having. We don't know what it is. Here also we are using. We don't know what it is. But observe it very careful. What is buffer? See here, buffer means what? We are reserving 4096 bytes exactly. So here address should be specified, but in this image it is not visible exactly. Okay, then later what is buffer end? What is buffer end? After this allocation, okay, whatever the empty space is available in case of the byte, okay, that memory location will be considered as a buffer end. Then length also we are having. Okay, length of the record of what? How many words? One word it is. Means total 24 bits. Okay, 24 bits. Length is equal to 24 bits exactly. Okay, so the address of this will be specified over here. That is the value of length exactly. Okay, so these are all information is available in this record exactly. So, but now just observe. Now, we are not defining any particular operand, okay, which may be referred by the other operand or other control section. So here we are skipping the external definition over here, okay. But just observe, read record. This is second name, okay. C section. C section means it indicates that the end of the first control section and the beginning of the second. After ending this here exactly at the bottom of this program, we are having one more section. We are calling the write record C section. Means that is the name. The control section name is write record. Okay, how to indicate that it is a control section? By using a directly called as C section. Okay, now just observe external reference we are having means these are the operands which are defined in some other control section. So where they are defined exactly, buffer means this location, buffer end means this location, length means this location exactly. They are from main program or they are from the first control section exactly. Okay, so like this we are identifying which are externally defined, which are externally referenced exactly. Okay, fine. So we were saying something regarding like some significant identification should be there, like proper alignment of information should be there so that the linker and loader can provide a proper values over there, right? For that we are having a next topic called as handling external reference exactly. So here we will be dealing with three different cases. Okay. So in case number one, just observe, you have an address location called as 003. Okay. Here we are having a label called as a C loop. Okay, we are having the instruction called as jump to subroutine. We are using the format number 4 instruction. Okay, read record example. Okay, so this is a sample instruction from first code section. Sorry, first control section exactly. Okay, means in first control section we are defining this read record as a just observe. Okay, we are defining it as what? What exactly it is? External reference exactly. Okay, so now the thing is your assembler don't have any information regarding this read record exactly. What is read record? Where they are available, where they are stored, such type of information is not at all available right now. Okay, so when we go for the second control section, okay, there we will be getting to know like, yes, this is what the original address or this is what the value of read record exactly. Okay, up to now, up to there, okay, what we do, we will be using a relative value which is invalid for the read record exactly. 4B1, including the flags, okay, it is to represent J sub exactly. Yeah, but the address of this read record, we will remain it as 0. We will remain it as 0. When your assembler or when your loader as a linker identifies this read record with its original address, so everywhere wherever it has placed 0 in the place of read record, it will be overwritten with original value of read record. Yeah, so here we are having some like procedure. The operand read record is an external reference. The assembler has no idea where read record is. Insert an address of 0. Can only use extended format to provide enough rooms. Okay, so here, okay, that is relative addressing for external reference is invalid. Okay, the assembler generates information for each external reference that will allow the loader to perform the required link. Okay, that is the job of assembler and your linking or linker, we are calling it as, okay, who will place the original value over here. But initially it will be looking like this. Then we are having one more condition. See here, this is the example from control section 2. Control section 2. Okay, see here. Here we are using buffer and buffer length, right? Okay, so here we don't have information what is the value of buffer, what is the value of buffer end exactly, but it is defined over here. So initially your the assembler will set the value as 0 itself. Okay, later it will be computed. Okay, so we'll see that how it will be done and all. Okay, there are two external reference in the expression buffer end and buffer. Okay, so buffer end and buffer. Okay, the assembler insert a value of 0. Okay, passes information to the loader. Okay, information to the loader. Now what loader will do is add to this data area the address of buffer end. So the loader will find what is the buffer end, okay, where it is defined. So what it will do, it will just add the value of buffer end to this data area. What is the data area? 0 exactly. So buffer end value will be added to this. Later, I need to subtract the value of buffer exactly. Why? Because I want to get a difference of buffer end and buffer. So first what I did, I'm adding the buffer end value to the 0. So finally I will get around 1000, feel that. Okay, if buffer value is 200, okay, then it will be subtracted exactly. So 1000 minus 200, 800 will be remaining. So what you are expecting over here, 1000 minus 200, obviously you will be getting 800 itself. So such type of computation will be done in case of case 2. Then case 3, on line number 107, based on previous example, buffer end and buffer are defined in the same control section and the expression can be calculated immediately. See, in case number 1, okay, where buffer end and buffer is defined, okay, there if you have this type of expression like buffer end minus buffer, then itself it will be calculated. Okay, we no need to place the result as 0, then later add the buffer end value, then later subtract the buffer value. That is not at all required exactly. Okay, directly it will be computing the result. Okay, see, this is what the example. See here, read record we have, right? And write record we are having. They are what? External reference exactly. So here, like for handling the plus J sub, okay, so this will be available 4B1, but read record, okay, which is considered as a 0, okay, right now. So you'll be placing 0 over here. For write record also you'll be placing 0. Okay, then up till now, whatever discussed, that is based on a logic. Now we need to go for the function. Okay, like it should be performed implementation exactly. So here we'll be managing two different records exactly. Okay, one is for handling the reference and definition, and one is for handling the modification record exactly. Sometimes it is required. So now we'll see how to handle this external definition. Okay, we are calling it a defined record. So column number 1 will be identified by capital D, that indicates defined record. So column number 2 to 7 will be name of the external symbol defined in this control section. Then 8 to 13, whatever the column we are having, relative address within this control section in case of a hexadecimal. Okay, means name of the particular symbol which is defined in this control section and what is the relative address. That also should be identified. Then later 14 to 73. Okay, so many columns are available. Okay, there what we need to do, we need to go for next such type of external definition, name with their address, So repeat information in column number 2 to 13 for other external symbols. So next slide we will find the results here. D we are having. Okay, it is followed by what? First column is D. It is followed by name of the operand buffer, where exactly they are stored that information. Later buffer end, where exactly they are stored that information. The length, where exactly they are stored. Such type of information will be managed by definition record. Then reference record or refer record we are calling that. First column will be identified by capital R. Okay, it indicates the reference record it is. Second, 2 to 7. Okay, column number whatever we are having, that will be indicated as name of external symbol. Okay, referred to in this column section. Okay, name of the referral, name of the external symbol referred. Okay, to in this control section. So that should be identified. Then later, name of other external reference symbols. Okay, that also must be identified exactly. So here, just observe See here. Okay, R, the name. First thing should be the name. Later, next one, next one, next one is continuous exactly. That's why we are calling it as 2 to 7, first one. Later, 8 to 73. Okay, if any other such type of references are available, that will be mentioned. Okay, but here one thing you need to notice, we are not mentioning the address, right? Because we don't know what is the address. Because of that, here you will be placed with 0. Observe it very careful. Okay, then later. Modification record, you already know. Okay, regarding this, capital M is the modification record indication. Starting address of the field to be modified, hexadecimal, half length, like half byte, based on that will be. Okay, then external symbol whose value is to be added or subtracted. Okay, from the indicated field. Okay, if such type operation is expected, so in case of buffer and buffer, okay, what we do, we are adding some value, then later we go for the subtraction such that if anything is required, okay, that can be mentioned over here, okay, by using operator like plus and minus. So we can observe over here, sorry, we can observe this here. Everywhere we are having a modification record. Okay, so this is the place where we need to add the address of buffer exactly. Value of buffer should be added in this particular location. What is that location? In a location of 18th byte. 18th byte, we need to add the value of buffer. So here in 21st byte, we need to add the value of length exactly. In 28th byte, we need to add the length of buffer end. Okay, in 28 byte itself, we need to subtract. We need to subtract. See here, this indicates, okay, it should be added and it should be subtracted. So this is how your assembler together with linker will deal with the external references and the control section. Okay, students. So this finishes the machine independent features of assembler. So in next session, we'll be discussing regarding the design consideration for the assembler. Okay, that we will discuss based on pass-on assembler and pass-through assembler. Okay, how it will be done on that. Okay, we'll go through that. Okay, thank you, students. So we will meet with next lecture in next class. Thank you.